All right, let's take a deep dive into the universe.
Oh,
We're going on a cosmic journey,
sounds fun.
exploring its origins and evolution,
All right.
and some of the mysteries that baffle scientists even today.
Yeah.
And we're basing this journey on Cosmic Chronicles, exploring the universe,
Mhm.
the source that you provided.
That's the one.
So we'll be diving deep into all the insights from this.
Okay, sounds good.
Now, when we talk about the universe, we're talking about something that's 93 billion light years across.
Yeah,
That's just the observable part.
that's right.
It all started from a single point.
A single point, incredibly dense.
Yeah, so how did we get from a tiny point to a vast universe?
Well, that's where the Big Bang comes in.
Okay, so the Big Bang.
It's not just a catchy name, it's actually the prevailing scientific explanation for the universe's origin.
So it's more than just a big explosion.
Yeah, it's not an explosion in the traditional sense.
So what is it then?
It's a rapid stretching of space itself.
Okay, so it's not like something exploded into space. Space itself started expanding.
That's it.
That's kind of hard to wrap my head around.
It is, and it gets even more mind-bending.
Okay, how so?
Well, this expansion wasn't just any expansion.
Right.
It was a period of super fast growth called cosmic inflation.
Cosmic inflation.
Yeah, imagine a balloon inflating faster than the speed of light.
Okay, that's fast.
That's cosmic inflation.
And why is that important?
Well, it solves some major puzzles.
Okay, like what?
Well, for instance, the universe has this remarkable uniform temperature,
Yeah.
even in regions that are so far apart that they could never have been in contact with each other.
That is strange.
Right. So cosmic inflation provides a solution.
Okay.
It says that the rapid expansion stretched tiny uniform regions to these enormous scales.
Okay, so it's like taking a tiny patch of dough and stretching it to the size of a giant pizza.
That's a good way to put it.
It might be huge, but it's still made from that same smooth dough.
Exactly, and this wild growth spurt didn't last forever.
So what happened?
Eventually, inflation ended, and the universe continued expanding, but at a more normal rate.
Okay.
But it wasn't over yet.
So the drama continues.
Yeah, the early universe was a chaotic place.
What do you mean?
It was incredibly hot.
Hmm.
Dense soup of energy and fundamental particles.
So we go from a tiny point to super fast expansion and then to cosmic soup.
That's a good way to think about it.
So what happened?
As the universe expanded and cooled, those particles started to clump together, forming the first protons and neutrons, the building blocks of atoms, the very foundation of matter.
Yeah.
It's like watching ingredients mix and combine to create something totally new.
I like that analogy.
And about 380,000 years after the Big Bang,
Okay.
the universe cooled enough for those protons and neutrons to capture electrons,
So what did that create?
the first atoms.
The first atoms.
That's right.
Didn't you say that's a really important moment?
It is a critical point.
Okay, wow.
It's a transition
From what to what?
from a universe full of free particles to one filled with atoms.
Okay.
Before atoms formed, light couldn't really travel very far.
Why not?
It was constantly bumping into free particles getting scattered everywhere.
Oh, I see.
But once atoms formed, light was free to travel.
Okay.
It's like the universe suddenly became transparent.
Wow, so how do we know about this change?
That's where the cosmic microwave background radiation comes in.
That rings a bell.
Remember that light that was free to travel after atoms formed?
Yeah.
It's still traveling today.
Really?
And we can detect it
As well.
as a faint glow coming from all directions in space.
So it's like an echo of the Big Bang.
It's a snapshot of the universe
From when?
from 380,000 years after its birth.
So we could actually see a remnant of that early universe.
You got it.
That's incredible. What does it look like?
Well, not a visual image in the way we think of it.
Okay.
Scientists detect it as microwaves.
Oh, okay.
And when they map these microwaves, they find a pattern of tiny temperature fluctuations.
Temperature fluctuation.
They tell us about the early universe,
Like what?
its composition, density, and even the seeds of future structures like galaxies.
Wow. So they can learn a lot from this afterglow.
I can.
So we've gone from this tiny, dense point to a universe filled with atoms and this ancient light.
And it keeps going.
What happened next?
Well, gravity started pulling those atoms together,
Okay.
forming clouds of gas and dust.
All right.
These clouds eventually collapsed.
Under their own weight?
Yes, igniting the first stars.
The first stars.
Massive, incredibly bright. And they didn't just illuminate the universe.
What else did they do?
They played a crucial role in creating the elements.
The elements that make up everything.
The carbon in our bodies, the oxygen we breathe.
Right.
The iron in our blood, they're like cosmic alchemists.
Transforming the basic ingredients of the universe into the building blocks of life.
Exactly.
So the stars are like cosmic factories.
Churning out the elements that would eventually make up planets.
And even us.
That's right.
So as stars lived and died, what happened?
They clustered together to
form first galaxies.
vast collections of stars, gas, dust, and planets.
That's our universe.
It's mind-blowing how scientists figured all this out.
Yeah, it's like detective work.
How so?
They have these powerful tools and techniques.
To reconstruct the past.
Exactly.
So what tools do they use?
One of their most powerful tools is the telescope.
Okay, the telescope.
Telescopes like Hubble and the James Webb Space Telescope,
Yeah.
they act like time machines, capturing light from incredibly distant objects.
I see.
Because light takes time to travel, the farther away an object is, the further back in time we're looking.
Wow, we can actually look back in time.
It's cosmic archaeology.
Digging through layers of time to uncover the past.
That's right. And there's more.
What else did they use?
Another key tool is particle physics experiments,
Hmm?
like those at CERN's Large Hadron Collider.
Okay.
These experiments recreate the extreme conditions of the early universe.
They do. They smash particles together at incredible speeds
To what end?
to study the fundamental forces and particles that shaped everything.
So they're recreating the Big Bang in a lab.
On a tiny scale, yes.
So telescopes for looking back in time and labs for recreating the early universe.
That's how they do it.
Pretty impressive
And this combination has led to some remarkable discoveries.
about the universe's past.
Yes, but it's also revealed some profound mysteries.
What kind of mysteries?
It turns out that all the matter and energy we can see,
You mean like
stars, galaxies, planets, gas, dust, light,
all that?
it only makes up about 5% of the universe.
What,
The rest is something we can't see or interact with directly.
what could that be?
We call it dark matter and dark energy.
Like matter, dark energy.
They're mysterious.
Tell me more.
Dark matter makes up about 85% of the universe's mass.
85%.
Wow, but it doesn't interact with light.
So we can't see it.
That's right.
So how do we know it's there?
Because of its gravitational effects.
Like what?
Galaxies rotating faster than they should based on the visible matter.
So it's like an invisible scaffolding holding everything together.
A good analogy.
And then there's dark energy.
Even weirder.
How so?
It's a repulsive force seems to be driving the accelerated expansion of the universe.
So dark energy pushes things apart.
Well, dark matter pulls things together.
Like a cosmic tug of war.
We don't know who's winning.
So these are big questions.
What are they, exactly?
Yeah.
How do they influence the universe's evolution and its ultimate fate?
It's pretty incredible.
The universe is full of surprises.
From the Big Bang to invisible forces shaping the cosmos, make you realize how much we still don't know.
We've just scratched the surface.
Okay, so we've talked about the Big Bang, stars, galaxies, even touched on dark matter and dark energy.
Quite a journey.
But we've mostly been looking back in time.
Right.
What about the future of the universe?
Now you're asking the big questions.
What does the universe have in store for itself?
Well, predicting the universe's fate is kind of like predicting the weather.
How so?
Well, imagine trying to predict the weather a million years from now.
Yeah, that'd be impossible.
We have some compelling theories about the universe's fate,
Okay,
but the ultimate answer is still a mystery.
I see. And why is that?
Because of those enigmatic forces we talked about.
Dark matter and dark energy.
Exactly. They make it really tricky.
Okay, so what are some of the leading theories?
About how the universe might end.
Yeah,
One scenario is the big freeze.
the big freeze.
It suggests that if dark energy keeps dominating and accelerating the expansion,
Okay.
galaxies will eventually become so far apart.
Yeah.
They'll be like isolated islands in a vast empty sea.
And then what?
Stars will burn out, their fuel will be exhausted,
Right.
new stars won't form.
Okay.
The universe slowly descends into this cold, dark, lifeless state.
That sounds kind of bleak.
It does, but there are other possibilities.
Okay, anything a bit more dramatic?
How about the big crunch?
The big...
It says if the density of matter is high enough,
Right.
gravity could overpower the expansion driven by dark energy.
So instead of expanding forever,
The universe would slow down, stop, and then start to contract.
everything collapses back in on itself.
Imagine it reversing course.
Yep.
Galaxies drawing closer, temperatures rising as space compresses,
Yeah.
and eventually everything converges back to a single, incredibly dense point.
Wow, like a cosmic reset button.
Sort of a fiery, dramatic end.
Definitely a contrast to the big freeze.
Are you ready for another possibility?
Sure, hit me.
There's the Big Rip.
The Big Rip. What's that?
It's kind of a middle ground between the freeze and the crunch.
Okay.
The Big Rip hinges on the idea that dark energy doesn't stay constant.
What do you mean?
It gets stronger over time.
Oh, so it's not just pushing things apart.
Right. If it keeps intensifying,
Yeah.
it could eventually overcome all other forces.
All other forces, like what?
Like gravity holding galaxies together.
Okay.
Even the forces binding atoms.
Wow, so everything would be torn apart.
Down to the smallest particles.
That's intense.
A pretty violent end to the universe.
So we've got the Big Freeze, the Big Crunch, and the Big Rip.
3 very different endings.
Which one is most likely?
That's the million-dollar question.
What do you think?
Unfortunately, we don't know yet.
Why not?
It depends on the nature of dark energy.
Dark energy again.
Is it constant or does it change?
We just don't know enough yet.
Not yet, but we're working on it.
That's kind of exciting.
And a bit unnerving.
To think the universe's fate rests on this force we barely understand.
It shows how much we still have to learn.
It makes you think, where do we fit into all of this?
With all this talk of cosmic scales and the fate of the universe, it's easy to feel small.
Insignificant, even.
But I think there's a different way to look at it.
How so?
We are, in a sense, the universe becoming aware of itself.
What do you mean?
We're made of the same stardust that formed the first stars.
Right. We talked about that.
The same atoms forged in supernovas.
So we carry the history of the cosmos within us.
And through science, we're unraveling that history.
Understanding our place in it all.
That can be incredibly empowering.
I like that.
Yes, we are small.
The universe is vast.
But we can contemplate these questions.
Explore the universe.
Try to understand its mysteries.
That's pretty remarkable.
It is.
It's like Carl Sagan said, we are a way for the cosmos to know itself.
A powerful quote.
Gives me chills every time.
So even though we don't know how it all ends,
we have this incredible opportunity
to explore,
understand,
appreciate the beauty and wonder.
And who knows, maybe someday we'll be able to influence its destiny.
Shape the future of the cosmos.
That's a thought.
Sounds like science fiction.
But we've come so far.
It's impossible to predict what we'll achieve.
Okay, so what's next?
Well, for now, let's shift our focus.
To what?
To some of the most fascinating implications of this cosmic journey.
Okay, sounds good to me.
We'll be back soon to delve into what it all means for us here on Earth.
Welcome back to our cosmic journey. We've explored the universe's origins.
Its evolution.
Possible endings.
Yeah.
But now let's bring it all back home to Earth.
Right.
What does this cosmic perspective actually mean for us?
It's a good question. When we look up at the night sky, easy to feel small.
Insignificant.
Yeah, in the face of such vastness.
Yeah.
But you can also view it from another perspective.
Okay.
And it's incredibly empowering.
Okay, tell me more.
Consider this. We are not separate from the universe.
Sure.
We are the universe experiencing itself.
Okay.
The very atoms that make up our bodies, the carbon in our cells, the oxygen we breathe, they were all forged in the hearts of stars.
Billions of years ago.
Oh, that's right.
It's true. We are literally made of stardust.
We are.
It's a reminder that we're part of this incredible cosmic story.
We're not just passive observers.
Yeah, we're active participants.
Exactly. And that realization,
that interconnectedness with everything in the universe,
it can change how we view ourselves.
A planet.
Our place in the grand scheme of things.
So how does this cosmic perspective actually shift our thinking?
How can it impact our lives?
Yeah.
Well, for one thing, it fosters the sense of awe and wonder.
Okay.
Knowing that we're part of something so much larger than ourselves.
Right.
That we carry within us the history of the cosmos. Yeah. It instills a sense of humility.
Perspective.
Yeah, it allows us to see our everyday concerns in a new light.
Appreciate the beauty and fragility of life on Earth.
That's it.
It's like taking a step back and seeing the bigger picture.
Right.
Realizing that our problems,
while important,
yeah,
they're fleeting in the grand cosmic timeline.
That's a good way to think about it.
This shift in perspective can also inspire a sense of responsibility.
Oh, how so?
If we recognize that Earth is our only home,
right,
this precious oasis in the vastness of space,
yeah,
we become more conscious of the need to protect it.
So it's moving from an anthropocentric view, where humans are at the center of everything,
right,
to a more ecocentric perspective.
Recognizing the interconnectedness of all life.
The importance of preserving our planet.
For future generations.
That's a powerful thought.
Our cosmic journey reminds us that we are not just inhabitants of Earth, we are caretakers.
This is this tiny, fragile world.
In a vast and often indifferent universe.
It really puts things in perspective.
It does, and that brings us to another crucial aspect.
What's that?
This cosmic perspective encourages a spirit of exploration and discovery.
Okay.
Knowing that we're part of this grand unfolding story, that there's so much we still don't know
about the universe.
It ignites our curiosity.
Drives us to learn more.
The universe is full of mysteries.
Dark matter.
Dark energy.
The ultimate fate of the cosmos.
All these unknowns beckon us to explore.
To push the boundaries of knowledge and understanding.
It's a quest that has no end.
A journey of discovery that inspires and challenges us.
That's right.
And it's a journey we're all a part of.
Whether we're scientists
or just curious individuals gazing at the night sky.
We all have the capacity to wonder.
To question.
To marvel at the universe's beauty and complexity.
Absolutely. And who knows, maybe one day you, the listener,
will make a discovery that changes our understanding forever.
It's possible.
This deep dive into the universe has been incredible.
Full of awe-inspiring discoveries.
Mind-boggling mysteries.
But perhaps the most important takeaway is this.
Never stop looking up.
Never stop asking questions.
Never lose your sense of wonder.
About the universe we call home.
Well said.
That's all for this episode of The Deep Dive.
Until next time.
Keep those minds curious.
Imagination soaring.
We'll be back soon with another fascinating topic to explore together.